Hello students, so we were discussing about the work energy in power chapter. We have already discussed about what are different types of work done we have discussed. Today let us discuss a topic related with one more topic which is called as the energy. Now what is your energy? Energy, suppose as for example if I consider me, okay, if I consider me, so how much amount of work I can do. How much amount of work I can do, that depends on my energy, what type of energy I have. Okay, so suppose if you give me some work and I am not able to do that work, that means my capacity of doing that work is not enough. Okay, so you can measure the energy of any body or any human being or any, suppose car engine, anything you want to calculate the energy, that depends on how much you have the capacity of doing that work. So therefore, we can consider that energy is a capacity of doing work. Okay, energy is called as a capacity of doing work. This energy we can divide it into many parts. There are different forms of energy. We have the electrical energy, magnetic energy, then electrostatic energy are there, then tidal energy are there, wave energy are there. There are numerous numbers of energy, each and every has energy forms. But here we'll be not discussing about that energy forms, we'll be discussing only about one form of energy, that is your mechanical energy. Okay, so we'll be discussing about the mechanical energy. Now what is the mechanical energy states? This mechanical energy can also be divided into two parts. One is your kinetic energy. Okay, one is your kinetic energy. The other one is your potential energy. Okay, one is your kinetic energy and one is your potential energy. I think you have already got about this in about around class 9 you have got. What is the kinetic energy and potential energy? Suppose as for example, if I consider a bow and arrow experiment, suppose when I stretch the bow. Okay, when I stretch the bow, the string attached to it. Okay, the string attached to it, what happens? It gets elongated. Like suppose, if this is your bow, this is your string. So when you stretch it, it gets elongated. That means the original shape of the bow you have changed. So when you change the shape of a body or a size of a body, or we can consider as a configuration of a body, we consider that body has attained a potential energy. Okay, similarly, suppose when you attach an arrow to it. Okay, when you attach an arrow to it and when you release that arrow, so what will happen? This arrow will move ahead. This arrow will move ahead. That means your arrow will be in motion. So that we can consider as possessing kinetic energy. So if a body is at rest, or if you change the configuration of a body, we consider that type of energy as a potential energy. And if a body starts moving, the energy gained by the body is called as a kinetic energy. So kinetic energy is the energy possessed when the body is in motion. Similarly, potential energy is the energy possessed by a body when the object is at rest or change in configuration of a body. Change in configuration of a body. Configuration means which we call as the shape and size of a body. If you change it, you will get potential energy, as I have already shown this. Okay, now this is the different forms of energy. There is a mechanical energy which can be divided into kinetic and a potential energy. So in this chapter, we will be mainly discussing about this form of energy. So first of all, let us discuss about the kinetic energy. So I have already told what is the kinetic energy. Energy possessed by a body when the object is in motion. That energy is called as a kinetic energy. So the kinetic energy has a formula given by half mv square. So let us derive this formula. What is the formula for the kinetic energy? How will you get to this formula? Okay, so for that we'll be doing kinetic energy. We'll be taking kinetic energy and we'll be going to derive a formula for it. Okay, let us suppose we have to consider a body of mass m. Okay, consider a body of mass m which was initially at rest. A body of mass m which was initially at rest. That means its initial velocity will be 0. Okay, we consider a body which is initially at rest. You apply a force to it, so the object will be getting displaced to a different position. Suppose this is point A, this is point B, and the body is displaced by a distance s. You are applying a force, and as we know, if I apply a force on the object, then according to the Newton's second law, it will be force is equal to mass into acceleration. That means your body will get accelerated. Okay, when we apply a force, then body gets accelerated. So we can write F is equal to m into a, mass into acceleration. Then mark this as equation number 1. Again, we know that v square minus of u square is equals to 2as using the equation of motion. So as we know that the initial velocity, I have already considered that your initially object was at rest. So your initial velocity will be 0. So it will be v square is equals to, it will be 2as, because u I have placed as 0. So what will be a here? A will be equals to v square by 2s. So we have got the value of the acceleration. So if I put this value of acceleration in equation number 1, putting a in equation number 1, so what will you get? We'll get as force is equals to mass. In place of a, I'll put v square by 2s. Okay, it will be mv square by 2s. Now, work done on the object. So what will be the work done on the object? We know that work done is equal to force into displacement. So W will be equal to force into displacement. Force we have already got, then this mv square by 2s into displacement we have got s. So this s and this s will get cancelled. So what will you get? You get the formula as half mv square. Okay, we have got the formula as half mv square. So this is the formula for the kinetic energy. So what you have to write it below. This work done will be stored as kinetic energy of the body. Therefore, in place of W, you have to write that it will be E is equals to half mv square, or kinetic energy is equals to half mv square. So this you have to write. I am repeating it again. This work done will be stored as kinetic energy in the object. Therefore, kinetic energy equals to half mv square. So this is the formula for the kinetic energy. Clear? So let us now move to the next part, that is about the potential energy. Clear? So once more I want to tell. This work done why I have considered as a kinetic energy, because after application of the force, body is getting displaced, and since your body is in motion, as I have already told, if your body is in motion, the energy gained by the body will always gain kinetic energy of the body. So therefore, this work done will be stored as kinetic energy. Clear? Let us move to the next part. Okay, then next we have the next topic. We have the work energy theorem. Now, what is the work energy theorem states? Work done in a body, is equal to change in kinetic energy of a body. Change in kinetic energy of a body. That means I can write W is equals to half mv square minus of half mu square. Okay, this is the formula for the work done. Okay, this is the formula for the work done, and this formula that I have written is called the work energy theorem. change in kinetic energy. Final kinetic energy minus of the initial kinetic energy. Clear? So this is the work done. But here the formula derived here, this is for the constant force. Okay, this is for constant force. Clear? Now one more will be doing the work energy term, that will be doing for the variable force. Constant force, variable force, I have already discussed. Constant force, if you apply throughout the whole time, if your force is constant, that is called as constant force. And if you change the value of the force throughout the whole time, that we call as a variable force. So we'll be deriving both the formulas. First of all, let me derive the work done by constant force. We'll consider the same condition. Proof. We'll consider that again you are considering an object having a mass m, you are applying a force F. So if you apply a force F on the object, your body will get displaced by distance S. Okay, and as we know, if you apply a force on the object, your body will get accelerated. But here, what I have considered, here you have to consider that your initial velocity is not zero. That means your body is actually moving, but you are applying some additional force on it. Okay, additional force on it. Initially, your object is not at rest. Remember that. Okay, so when we apply a force, then force is equals to mass into acceleration. Okay, force is equals to mass into acceleration. Mark this is equation number 1. Again, v square minus of u square is equals to 2as. Okay, is equals to 2as. So this implies a will be equals to v square minus of u square by 2s. This is equation number 2. I find out the value of acceleration. Now this acceleration value I put in equation number 1. So F will be equals to mass into acceleration. So acceleration will be v square minus of u square divided by 2s. Okay. So force we have got. Now work done. W will be equals to force into displacement. Okay, W is equals to force into displacement. So force, if I put it from here, so m v square minus of u square by 2s into, it will be s. So s and s will get cancelled. What will you get? You will get as half mv square minus of half mu square. So you can see we have got the work done as change in kinetic energy. You can see this. So this is your work energy theorem for a constant force. Clear? So this much for today. In the next class I will be discussing the same topic, that is a work energy theorem, but I will be doing it for the variable force. Okay, thank you.